The Great Barrier Reef has just recorded its largest annual decline in coral cover in 39 years, and the organism that powered every single recovery is the one that died first. In the southern reef, coral cover collapsed by 31% in a single year. In the north, 25%. Individual reefs lost up to 70% of their living coral between one summer and the next. At One Tree Reef, a protected marine research station in the southern Great Barrier Reef, a University of Sydney team tracked 462 individual coral colonies from the peak of the heat wave through to winter. By July, 95% of the fast-growing Acropora, the staghorn and table corals that build reef structure faster than any other species, were dead. Tourism operators in the Whitsundays started offering refunds to snorkelers who surfaced and asked where the colour went. And the Bureau of Meteorology's latest climate models show every single one of them projecting the same thing. El Niño is possible by the end of winter 2026. That matters because El Niño is the accelerant. It suppresses the monsoon, strips away cloud cover, and pushes coral sea temperatures above the bleaching threshold. The last time El Niño arrived during a weakened reef was 2016. That year triggered the most catastrophic mass bleaching in the reef's recorded history. But here is the detail that reframes everything above. The Acropora corals that died at 95% mortality are not just any species. They are the fastest growing corals on the reef. They are the ones that colonized damaged areas first. They are the ones that rebuilt the reef to record high coral cover between 2017 and 2024. Every recovery the Great Barrier Reef has ever made depended on Acropora growing back faster than everything else could die. The reef's accelerator and its most fatal vulnerability are the same organism, and in 2024, the accelerator was destroyed. The question nobody can answer yet is whether the reef can recover without the one thing that made recovery possible. To understand the speed of this collapse, you need to see the timeline tighten. The first modern mass bleaching hit the reef in 1998. The second came 4 years later in 2002. Then nothing for 14 years. In 2016, the northern third of the reef was devastated, 22% overall coral mortality in a single summer. In 2017, it struck again. Back-to-back mass bleaching for the first time ever recorded. 3 years later, in 2020, another event occurred, this time during La Niña, the ocean cycle that was supposed to bring cooler water. That assumption shattered. In 2022, bleaching returned. In 2024, the most spatially extensive event ever recorded engulfed 74% of the reef's 3,000 individual systems, north, central, and south simultaneously for the first time. Then in 2025, the reef bleached again. 2 consecutive years. The second time that has happened in a decade. 8 mass bleaching events since 1998. The interval between them has compressed from 14 years to 4 to 2 to 1. The reef is being hit faster than it can heal. The Great Barrier Reef stretches 2,300 kilometers along the Queensland coast, from the Torres Strait near Papua New Guinea to Bundaberg in the south. It covers 346,000 square kilometers, roughly the size of Italy. It contains over 3,000 individual reef systems. When the Australian Institute of Marine Science surveyed 124 of those reefs, between August 2024 and May 2025, they found that 48% had lost coral cover. Not in a decade, in 1 year. Here is what the headlines did not tell you. Coral is not a rock, it's an animal. It survives through a partnership so precise that a single degree of temperature changes everything. Inside the tissue of every living coral sits a microscopic alga called zooxanthellae. The alga photosynthesizes. It feeds the coral sugars. In return, the coral gives the alga shelter. This partnership is what builds reefs, what makes them grow, what gives them color, and what keeps 3,000 reef systems alive across an area the size of a country. But the partnership runs on a razor-thin temperature margin. Raise the water 1 degree Celsius for 4 weeks, and the coral expels the alga. The color drains, the coral turns white. Without the sugars, it starves. If the temperature drops back in time, the alga returns. If it does not, the coral dies. What happened in 2024 was not a freak spike. The ocean temperatures that triggered the bleaching were the warmest in 400 years. A study published in Nature confirmed it using coral core records stretching back centuries. The heat driving this is not temporary. It is the new baseline. And this is where it gets worse. The heat did not just kill coral, it killed coral at depths that were supposed to be safe. For years, scientists operated on a hypothesis called deep refugia, the idea that corals below 15 meters would be shielded from surface heat stress and serve as a genetic seed bank to repopulate shallower areas after bleaching. It was the reef's insurance policy. At One Tree Reef, Professor Maria Burns' team measured water temperatures of 29 to 30 degrees at 20 and 30 meter depths. Degree heating weeks exceeded 8, the mass mortality threshold below 15 meters for the first time ever recorded. The deep corals bleached. The insurance policy failed. But that was only half the collision. The Acropora corals that died at the surface were the same ones that drove the reef's astonishing recovery between 2017 and 2024. Year after year, these fast-growing staghorns and table corals colonized the damage zones, rebuilt the three-dimensional structure, and pushed coral cover back toward record highs. Dr. Mike Emsley, who leads the long-term monitoring program at AIMS, described what has emerged over the past 15 years as increased volatility. He said coral cover now oscillates between record lows and record highs in a relatively short amount of time, where previously such fluctuations were moderate. Record growth, then record death, then growth again, then death again. Each swing bigger, each recovery window shorter. An ecosystem on a pendulum that swings harder every year. And then there is the detail buried in a 2024 study that almost nobody covered. Researchers from Ames and James Cook University found that even corals that survive bleaching and appear to recover suffer a 21% decrease in reproductive output. The coral looks alive, it has regained its color, but it is producing fewer larvae. The next generation is smaller before it even begins. Recovery that looks like recovery from the outside is, from the inside, a quiet decline. Now pull back and see the full scale. The bleaching of 2024 was not isolated. It was part of the fourth global mass coral bleaching event, the most extensive ever documented. It struck 84% of the world's reef areas across 82 countries. The severity was so far beyond existing measurement systems that the American agency NOAA had to add 3 new alert levels to its coral bleaching scale. The scale broke because reality exceeded what it was designed to measure. In Australia alone, it was not just the Great Barrier Reef. Western Australia's Ningaloo Reef, the country's other World Heritage Reef, suffered its worst bleaching on record in that same year. Professor Selina Stead, Chief Executive Officer of AIMS, said it plainly. This was the first time a single bleaching event affected almost all the coral reefs in Australia. Here is what happens next, and why it matters that you know this now. Thomas DiCarlo, an oceanographer at Tulane University, published a study in January 2026, projecting how often the reef will bleach for the rest of this century. Under current emissions, mass bleaching becomes a near-annual occurrence. Even under the most optimistic scenario, where corals steadily increase their heat tolerance and global emissions follow the lowest possible pathway, the average gap between bleaching events is only 4 to 5 years. Corals need 10 or more years to fully recover. His conclusion was stated directly. There is no realistic future this century in which the Great Barrier Reef returns to its pre-bleaching state. And now the Bureau of Meteorology's climate models, updated as of March 2026, show the La Niña that offered some protection over the past 2 years is ending. All models project a return to neutral conditions by early autumn, and all models indicate a shift to El Niño is possible by the end of winter, some as early as May. If El Niño develops, the summer spanning 2026 and 2027 will push coral sea temperatures above the bleaching threshold again. The reef enters that summer with less coral cover, fewer Acropora to rebuild, reduced reproductive capacity in the survivors, and deep refugia that no longer offer protection. Every buffer has been eroded. Every safety margin has been consumed. So the question is not whether the Great Barrier Reef will survive. Some coral will remain. Some species are more heat tolerant. The reef will not vanish entirely. The question is what kind of reef will be left. Will it be a reef that supports 1,500 species of fish, 4,000 types of mollusk, and a $6 billion tourism industry? Or will it be something simpler, flatter, less colorful, a reef in name, but not in the way anyone alive today remembers it? 500 million years of evolution built the coral reef. 28 years of bleaching have undone more of it than any ice age, any sea level change, any natural disaster in the reef's geological record. Before 2016, there was no evidence of mass bleaching in the Great Barrier Reef's entire 500-year coral record. What the reef survived for 5 centuries, it has now endured 7 times in less than 3 decades. And right now, as La Niña fades and the models lean toward El Niño, the water temperature around the world's largest living structure is still above average, and the next summer is already taking shape.